Now that we have been given a fair idea of the special set of numbers under sets and operations of sets, we want to now go ahead and see how we can list them in terms of question. Now the question here says, list the elements in the following set and determine the number of elements of each set. And P is equal to X such that X is equal to multiples of 3 less than 18. Then II says Q is equal to X such that X is a factor of 12. Then III. R is equal to X such that X is an even number between 5 and 21. Now with this, let us get a solution. We have been asked to do two things from the question. List and show the number of elements in the set. So I, the set P, we have X such that X is a multiple of 3, which are less than 18. So multiples of 3 are 3 times 1, 3. 3 to 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. 3 times 6 will give us 18. So then they are less than 18. So we won't add the 18 to it. So we end on 15. Why are we ending on 15? Because the condition said less than 18. So you can get your multiple of 3 or multiples of 3. But make sure they don't become equal to 18 or above 18. So this is the set P. It's a complete set. Now let's see how many members are in the set P. I have 3, 6, 9, 12, 15, making it 1, 2, 3, 4, 5. There are 5 members. So the number of members of P is equal to 5. So the set P has 5 members. III is asking for the set Q, and they want us to find the factors of 12. Factors of 12 are the numbers that can multiply to give us 12. Factors means what numbers can you multiply to produce that thing. So if you say factors of 12, I want pair of numbers I can multiply to get 12. Or the values that can divide 12 without a remainder. That is to say the numbers which can divide this 12 without a remainder. Now that qualifies to be factors of 12. So I can talk about 1 times 12 as my factors of 12. That means 1 will be the first number and the least for that matter. 12 will be the last and the highest number. So that's why I started with 1 and 12. Now I can talk about 2 and 6. So next 2, then I put 6 here. Then I can talk about 3 and then 4. So I put 3 here and I put 4. That means there will be no other number that can multiply to get me 12, or no other number that can divide 12 without a remainder except these ones. So the factors of 12 will be 1, 2, 3, 4, 6, and 12. These are the factors of 12. What does it mean? Pair of these numbers can multiply to give 12. So 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. Also, these numbers can divide the 12 without a remainder. So these qualify to be factors of 12. Now, if they are factors of 12, then they are for the set Q. So this becomes a set of values for Q. Now, let's see the number of elements. So N for Q, or number of elements in Q, will be 1, 2, 3, 4, 5, 6. We have 6 members of Q because when you count 1, 2, 3, 4, 5, 6, you get 6 elements or members in the set Q. So the number of members in the set Q will be 6. The last one will be III, which will talk about the set R. Now the set R talks about even numbers between 5 and 21. Now remember, even numbers are numbers that are divisible by 2. Meaning when you divide even numbers by 2, you will leave no remainder in the form of a fraction or in the form of a decimal. It will be evenly divided. So numbers that are evenly divided by 2 are called even numbers. And numbers between 5 and 21. That means 5 is not part and 21 is not part. So let us see between it. Now from 5 we go to 6. So 6 qualifies. 7 is not part, so 8. 9 is not part, so 10. 11 is not part, so 12. 14, 16, 18, 20. We can exceed 21 because it ends at 21. And then if we are having 20 as the last one, then 20 should be the final one. Because when you exceed 20 or exceed 21, you are wrong. So we shouldn't exceed 20. Let's put it that way. Let's even not talk about 21. Let's hold it down to 20. Because between 5 and 21, we have 20 as the last one and 6 as the first one. So these are the members for the set R, describing even numbers between 5 and 21. Now let's see, how many are they? The number of R. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 members for the set R. So this brings us to the end of how to list elements of a set, or listing the elements of a set. So you list them and you go ahead and get the numbers. And I believe that you'll be able to list and get how many numbers are in there or how many members are in the set. Take your time, go through this very well and understand as we go to the next stage of our set and operations on set.